Presentation of rational functions. So General Mathematics Quarter 1 Module 7. Okay, now let's answer what I know. So choose the letter of the best answer. Write the chosen letter on a separate sheet of paper. So number 1, which of the functions does the graph on the right belongs to? So this one. This is the graph of rational function. This is how a rational function graph look like. So number 2, complete the table using the equations f of x equals x minus 1 over x plus 1. Now the missing function of x here is when x is equal to 4, all you have to do is to substitute 4 to the x here. Substitute x by 4, that's 4 minus 1 over 4 plus 1. That's 4 minus 1 is 3 over 5. That's letter A. Okay, number 3, which of the following table shows the function y equals 2x plus 1 over x? All you have to do here is to substitute the value of x by 1. When your x is 1, it's 2 times 1, it's 2 plus 1, 3 over 1. So when your x is 1, your y is 3. When your x is 2, 2 times 2 is 4 plus 1, 5 over 2, 5 over 2 is here. So the answer is letter C. Number 4, from the questionnaire number 3, which represents the graph of the function. So function of x equals 2x plus 1 over x. Here is it, 2x plus 1 over x. What is the graph of this? So to graph this rational function, you have to equate first the numerator into 0 to find the x-intercept. So 2x plus 1 equals 0, 2x equals negative 1. You transpose positive 1 to the right side, positive 1 becomes negative 1. And here x is equal to negative 1/2 because you divide by 2 divided by 2, or by simply multiplication property of equality. So this is our x-intercept. It is where the graph crosses the x-axis. Now equate also the denominator into 0, and this 0 is equal, this is our vertical asymptote. Okay, this is the restricted value of x, wherein the graph could not pass. Even how strong the graph, it could not pass the vertical asymptote. And here the horizontal asymptote is 2, because to get the horizontal asymptote, what is the numerical coefficient of x is 2, and what is the numerical coefficient of x here? The leading coefficient of our denominator is 1, so 2 divided by 1, that's 2. So all you have to do is to draw first the horizontal asymptote, it's 2. Okay, when your y is equal to 2, here 2. And also your vertical asymptote is your y-axis. Our vertical asymptote is the y-axis. And plot also the x-intercept is negative 1/2 is here. Now what is the behavior of the graph when the function approaches to 0 from the left? Here is it, the behavior of the graph of function of x equals to x plus 1 over x. Now here, look at the graph. When the value of x is coming from the left, when the value of x is coming from the left of 0, so this is the basis, 0, or the vertical asymptote is the basis. So this is 0 here. When the graph, when the value of x is from its left going to 0, so the graph is going to negative infinity. So this is negative infinity when x approaches to 0 from the left. And what is the behavior of the graph or the function when your x approaches to 0 from the right? Meaning the function, the value of x is coming from the right here, from the right here. So what is the function, the behavior of the graph? It approaches to positive infinity. So this is the graph of this 2x plus 1 over x. So which is this one. Okay, here is it. It's letter A. Okay, next. Now, rational expressions can be described as a function where either the numerator and denominator both have variable in it. Below are examples of rational expression, except this is letter D. This is not a rational expression, it's because of the radical symbol. Okay, number 5, Reynolds manufactures aluminum cans in shape of a cylinder with a capacity of 500 cubic centimeter, 1/2 liters. The top and bottom the can are made with special aluminum alloy that costs 0.05 cents per square centimeter. The size of the can are made of material that costs 0.02 cents per square centimeter. Express the cost of the material for the can as function of R of the can. Meaning, what is the cost, the total cost of the entire can representing or using the radius. So here is it, a cylinder. So there are two circles in the cylinder, and area of the circle is pi r squared. Since there are two circles, now the area of these two circles is equal to 2 pi r squared because there are two circles. So 2 pi r squared. And each of the square units of this circle, its cost is 0.05. So therefore, 0.05, multiply it to the total area of the two circles, the answer is, the cost is 0.1 times pi times r squared. So this is the cost of the two circles. Now let's find out the cost of the side. So this one. So when we cut the cylinder, it forms like this, a rectangle. Now this one, the length of this is 2 pi r, or simply this is the circumference of the circle because this is circular, and circumference of the circumference is the length of the entire the circle, the length of the circle, and perimeter is for the polygon. So this is 2 pi r. The length of this is 2 pi r, represent the circumference of the circle and its height. And it was said here that the volume of the cylindrical can is 500 cubic meters. So here, volume of the cylinder equals pi r squared times height, or pi r squared the circle times the height. It's the volume already. So we have here the volume. Volume equals 500 centimeter cubes equals pi r squared times height. So let's find out this height by dividing both sides by pi r squared, dividing both sides by pi r squared, or simply multiplication property of equality. So our h is 500 over pi r squared. So this is our h. Remember, this is our h, and this is our length. Okay. Now, area is equal to length times width. So when we multiply the length, which is 2 pi r, this is the length 2 pi r, times the height or the width, which is the height, 500 over pi r squared. So you could multiply 2 times 500 is 1000, and pi r and pi r here cancel out. Pi r divided by r squared, the remaining is r. So the area of this rectangular side of the cylinder is 100 over r, and the cost of each square units of the side of the cylindrical can is 0.02 cents. So the cost is 0.02 cents times the area, which is 100 over r. Okay, so the answer is the cost of the side of the can is 20 over r. Okay, now here the total, if we add this 20 over r for the cost of the side of the can and the cost of the two circular bottom and top, so here is it. The cost of the can expressing r is equal to 0.1 pi r squared plus 20 over r. Okay, next. So which of the following graph of function of x equals x over x minus 2 using the values x equals negative 2, negative 1, 0, 1, and 2. Now, when you'll be substituting these 2, negative 2 on our function here, substitute x by negative 2 and x is negative 1, you could create a graph of a rational function. But how to graph a rational function? How to graph this function of x equals x over x minus 2? First is you equate this numerator on the 0, that's x equals 0, and the answer is the x-intercept. It is where the graph crosses the x-axis. Equate also the denominator into 0 to get the vertical asymptote. So x minus 2 is equal to 0, then x equals transpose, that's 2. This is vertical asymptote. Find also the horizontal asymptote. So there is a horizontal asymptote of this because they have the same degree. So the degree of the numerator is 1, degree of the denominator is 1. So therefore, there is a horizontal asymptote. And to get the horizontal asymptote, let's divide its numerical coefficient. This is 1 here, there is 1 here, so 1 divided by 1, so our horizontal asymptote is 1. Okay, if we will be finding out also the y-intercept, the moment the graph crosses the y-axis, so let x is equal to 0. So when your x is equal to 0, replace x by 0, replace x by 0, so our function of x equals 0. So our x-intercept is 0. So let's plot each of these points on our Cartesian coordinate plane. So first, let's plot the vertical asymptote, which is 2. So vertical asymptote, which is positive 2, is here. The graph could not pass through this vertical asymptote. It goes nearer to 2, but it could not pass through. This is very strong. Cannot be in, the graph cannot pass through. And here next to plot is the horizontal asymptote, which is 1. 1 horizontal asymptote. So y is equal to 1. And next to plot is the y-intercept, which is 0. Here, when x is equal to 0, y is equal to 0. So this is the x-intercept and y-intercept. So, how is the graph look like? So the graph look like this. So when our basis is 2, the vertical asymptote, when the value of x approaches to 2, coming from the left here, means when the value of x here, which is negative, 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 until here, until 0, until 1, until 2, could not be 2, the graph approaches to negative infinity. And when the graph also, when our x also, the values of x is coming from the right of 2, coming from here, the graph or the function of x or our functions approaches to positive infinity. So this is the graph. And where this be on our choices, it's letter D. Okay. Now, using the rational function g of x equals x squared minus 1 over x plus 1, what is the value of g of x when x equals 4? Simply substitute x, replace x by 4. Here, replace x by 4, 4 squared minus 1. Replace x by 4, 4 plus 1, that's 4 squared, that's 16. Minus 1 is 15. Divided by 5, it's 3. It's letter A. Okay, next, for number 8 and 10, consider the situation. A cylindrical soft drink can is to be constructed so that it will have a volume of 21.6 cubic inches. So write the total surface area of the can as a function of r, where r is the radius of the can inches. Still, we'll be using r. So there should be r in our equation, or in our function, there should be r. And our function is the surface area. And our dependent is, independent variable is r. Okay, looking back on the surface area of a cylindrical can, it is the area of the two circles, which is 2 times pi r squared, plus the area of the side, which is 2 pi times r times h. So this is the surface area of the cylindrical can. Now, we have here the given for volume. The volume also is equal to pi r squared times height. So pi r squared times height, and our volume is 21.6 equals pi r squared times height. Now, derive height, divide both sides by pi r squared here, or by multiplication property of equality. So our h is equal to 21.6 over pi r squared. So this is our h. Now, okay. Now, what is the question here? Write the total surface area using r. So here, surface area equals to 2 pi r squared plus 2 pi r times the height, which is 21.6 over pi r squared. So surface area equals 2 pi r squared plus, when you multiply this one, 2 times for 21.6, that's 43.2. And this pi cancel, r cancel, there is r on the denominator. So this is the answer. Okay, is there any answer like this here in the choices? There's none. Okay, there is none. So number 9, what should be the value of the function when values x approaches to 3? Let's skip this one because our answer is here. It's different from the choices. Okay, also this, what is the graph of our function? So we could not identify. So let's proceed to 11 to 13. So refer to the problem. Lina is doing mathematics tutorial for a summer job. For every tutorial, she charges an initial fee of 500 pesos per month, plus a constant fee of 200 pesos for each hour of tutorial. So which of the following equations best describes Lina's fee for each of her tutorial? So the initial is 500. So 500, this is constant, that's 500. Plus, every hour. How much is the fee every hour? It's 200. So it's 200x. Function of x equals 500, constant, money, initial payment, plus 200 every hour. And this is letter A. Okay. Which of the following table best represents Lina's fee for each of the tutorials? So if we will be substituting each hour, numbers of hours, like after 1 hour, so Lina will, the customer will pay, or the client will pay 700 pesos. So the answer is letter D. You just only substitute x by 1, 2, 3, 4 and solve. And here, if Lina spends 15 hours on a student and another 13 hours for another student in a month, how much will she earn? Write an equation that will best suit the situation. So there are 2 students. So first student initial fee is 500 plus 200 times 15 because 15 hours. She is rendering 15 hours of her tutorial, plus the other student, which is 500 plus 200, 500 initial payment plus 200 times 13 hours. Okay, so if you are going to evaluate this one, it's a big amount of money. About 1,000, more than 3,000, I guess. So for numbers 14 and 15, refer to the problem. There are 1,200 freshmen and 1,500 sophomores at SSG election meeting the advance at noon. After 12 p.m., 20 freshmen arrive at the gymnasium every 5 minutes, while 15 sophomores leave the gymnasium. Which equation best describes the total number of students who attended the SSG election meeting the advance? So therefore our y is the number of students attended the meeting the advance, and there is an initial of 1,200 freshmen. Yeah, but after 12 noon, there are additional freshmen every 5 minutes. Every 5 minutes. That's 20 every 5 minutes. So every 5 minutes, that's x, 20x. This is for freshmen. Plus, but the sophomores, there are 15 who will exit every 5 minutes. So therefore 1,500 minus 15x. Okay. What letter is this one? Letter A? Oh, letter B. Letter B. Okay. Simplify the answer in number 14 and we can get. So simplifying the 1,200 plus 1,500 is 2,700. 20x minus 15x, that's 5x. So this is the answer. And this is letter B. Okay. Now, independent assessment. In order to join a voice lesson class, you pay a 1,500 pesos fee. Then 500 pesos for each class you go to. What is the average cost per class? Or graph the function to show whether it forms a straight line or a curve. Now, here is it. The average cost is equal to 1,500 as the initial payment plus 500 for every class you want to go. Now, if you are going to go 10 classes, so 500 times 10. And how many classes? To get the average is to divide it also to the number of classes. So therefore, 1,500 plus 500x, this is number of classes divided by classes. So this is our rational function. Now, how are we going to graph the function to show whether it forms a straight line or curve? Yes, it forms a curve because this is a rational function. So here, equate the numerator into 0. 1,500 plus 500x equals 0. So 500x equals, Okay, transpose, that's 1,500. And you divide both sides by 500 or simply by multiplication property of equality. So x equals -3. So when you equate the numerator into 0, the result is an x-intercept. It is where the graph crosses the x-axis. So the graph crosses at -3. The value of x is -3. And what is our vertical asymptote? Oh no, wait. What is our vertical asymptote? So to get the vertical asymptote, equate this x, the denominator is 0. So our x equal to 0, 0 is our vertical asymptote. What is our horizontal asymptote? So do we have horizontal asymptote? Yes. It's because the degree of the numerator is the same as the degree of the denominator. So to get the horizontal asymptote, let's divide the numerical coefficient of x, which is 500, divided by numerical coefficient of x here is 1. 500 divided by 1, that's 500. So this is the horizontal asymptote. Y equals 500. So here, plot the vertical asymptote first. So the vertical asymptote is the y-axis. Okay, this is the vertical asymptote. And also, the x-intercept, it's -3 here. -3. And next is 500, the horizontal asymptote is here. So how does the graph look like? Okay. Now, what is the behavior of the graph? If you will be having a table of values, the behavior of the graph of this is, our basis is the vertical asymptote, which is 0. When the value of x is coming from the left, going to 0, from the left, it's going to 0, but not exactly touch 0. The behavior of the graph is going to the negative infinity. So you can find it when you'll be substituting in, you will be using, when you'll be making a table of values for this. And when the graph, when the value of x is coming from the right, from here, going, when x values is from the right, going to 0, not exactly 0, the behavior of the graph is going to positive infinity. So this is the graph of this one. Okay, represent this rational equation through a table and graph. Identify whether the graph forms a straight line or a curve. This is still a curve. It's because this is a rational function. But, okay, x squared plus 1 over x plus 1. So if you notice, the degree of the numerator is 1 greater than the degree of the denominator. So there is no, okay, there is no horizontal asymptote for this. Okay, there's no horizontal asymptote. What we have here is the oblique asymptote. Oblique asymptote. So this is how you are to graph this one. So p of x equals x squared plus 1 over x plus 1. Now, let's divide this one. Let's divide to find our linear asymptote or the oblique asymptote. So if you divide x squared plus 1 over x plus 1, we will complete first the polynomial expression into x squared plus 0x plus 1. So x squared to 1 constant. So here, let's write down by synthetic division 1, 0, 1. And our denominator of divisor is x plus 1. So divided by -1, x equal to -1. Now, 1, bring down 1 times -1, that's -1. 0 and -1, that's -1. -1 times -1, that's +1. 1 plus 1 is 2. So here is the x. This is 1x minus 1 plus the remainder 2 over x plus 1. Okay. Now, this is a uh, linear expression. So this is linear because exponent is 1. So to graph this one, our y-intercept is -1. Y-intercept is our -1. And our slope is 1 over 1. So the graph or the oblique asymptote passes through 1. It crosses 1 because our our y-intercept is -1. So our graph, our oblique asymptote graph is passes through -1. And our slope is 1 also. Okay. So rise over run is 1. 1 over 1. Rise 1. Run to the right 1. So this is 1 here. Okay, you connect the 2 points here, 1 and -1. So this is the graph of our oblique asymptote. The graph of our oblique asymptote. Okay, how is our graph look like? So this is how the graph look like here, oblique asymptote. Okay, our vertical asymptote, you equate this one into 0, x plus 1 equals 0, so x equals -1, here -1. So this graph could not pass through this vertical asymptote, and so as with our oblique asymptote. Okay, next. So in an inter-barangay basketball league, the team from Hermana Pausta won 12 out of 25 games, a winning percentage of 48%. We have seen that they need to win 8 games consecutively to raise their percentage to 60%. What will the winning percentage if they win 10, 20, 30, 50, 100 games? Can they reach 100% winning percentage? Of course, they can get 100% winning percentage. Now, if we will be solving this problem, 12 out of 25 games, and they need to win 8 straight games. The problem is, how many games should be played? Okay, so to solve this one, that's 12 over 25. This is 48%, plus 8 over x games. So 8 over 8 straight wins over, we don't know how many games to be played after winning, after 25 games. It's x. And this should be 60% winning percentage. So this is, okay, this is 0.48 or 48% winning percentage, 12 over 25. And this should be 12%. 48 plus 12 is 60. So how many games to be played? So 60% or 0.6 or 6 over 10 or 3/5. So here, substitute. 12 over 25 plus 8 over x equals 3/5. Now, what is the least common denominator? It should be 25x. So 25x, you multiply to the left side of our rational equation and to the right side. So you cancel out 25. So this is 25 cancel. That's x times 12. That's 12x. Then you cancel out x here. You multiply this one and this one. You cancel x here. So 25 times 8, that's 200. And here, when you divide 25x divided by 5, that's 5. 25 divided by 5, that's 5. X times 3, that's 5 times 3, that's 15x. Okay. Now, let's have your 200 transpose 12x to the right side, it becomes -12x. So 200 equals 15x minus 12x. So 200 equals 15x minus 12x is 3x. Or if you divide this one by multiplication property of equality, divide this, multiply each of the equation by 1/3 or divided by 3, our x is 66.6 games. So there's no 0.6 games, so run off, it's 67 games. So if you are to check, this is really 60%. Okay, now here is it. Let's answer. What will their winning percentage if they win 10, 20, 30, 50, 100 games? Can you reach 100% winning percentage? And try to substitute 300 games. Write your interpretations on the space provided. Okay, here is it. So 12 over 25 is 0.48. This is 0.48 or 48% winning percentage. 12 over 25 plus 10 over 300 and 0.48 plus, okay, 10 divided by 300 is 300ths. So if you add this one, that's 0.5133 or 51.3%. So if they are to win 10 games out of 300 games, their winning percentage is 51.3%. How about if they won 20 out of 300 games? So what is their winning percentage? It's 12 over 25 plus 20 over 300 is 0.48 or 48% plus 0.06 or 6% equals. So if you add this one, that's 0.5466 or 54.7%. Now, if they are to win 20 games out of 300 games, After winning 12 games out of 25, their winning percentage is 54.7%. So as with the next 30, so the same procedure, 12 over 25 plus 30 over 300, then 50, 12 over 25 plus 50 over 300, then you evaluate, simplify. Then 100 games, 12 over 25 plus 100 over 300, and get the winning percentage. Now, let's try to answer this one. Can they reach a 100% winning percentage? Yes, because that's 12 over 25 plus how many games to be won should be won out of 300 games so that they can get 100% winning percentage. So we do not know how many games, how many winnings this should do out of 300 games. Okay, so 0.48, the won already 12 out of 25 and it is 48%. And to get 100%, it's lacking 52%. 48% plus 52% is 100%. Now, how many games to be won? So, evaluate this one. This 100% or 1. Okay, the least common denominator is 300. So, you multiply 300 to the left side and the right side of the equation. That's 300 times 12 over 25. Okay, here is it. It's 12. 300 divided by 25 is 12. Times 12, that's 144. 300 divided by 300 is 1. Times x, it's x. 300 times 1, that's 300. So, you transpose 144 to the right side, that's negative 144. So, x equals 300 minus 144 is x equals 156 winnings. Try to check. They need to win 156 games out of 300 games so that they will reach a 100% winning percentage. Okay, thank you very much.